Hello, this is Mr. Ratoon, and these are our global warming and climate change unit notes. This would, I guess, would be part 4. The first two parts were labeled 1 and 2. I guess the third part was labeled greenhouse gases, so this is the fourth part that comes after it. So we talked about the different greenhouse gases, and now we're going to talk about sources and sinks. The elements that compose greenhouse gases, such as carbon, oxygen, nitrogen, they normally cycle through the environment, and they alternate between sources and sinks. Sources release elements into the atmosphere. For example, we are a source of carbon dioxide. Sinks store the elements. For example, trees will store carbon dioxide. They would be a sink. And the way I keep these two in check, or I remember these two, is I think of a sink. You know, what is a sink? A sink holds dishes. Now, I don't always do the dishes when I'm supposed to, but at least they store the dishes. So sinks store the elements. Now, soils, oceans, and trees tend to act as natural sinks for carbon. Each year, hundreds of billions of tons of carbon dioxide are absorbed by the soils, oceans, and trees. And then when these trees are cut down and burned, the stored carbon that was in those trees is released back into the atmosphere. So here's a diagram of what it might look like. And here's another visual of what it might look like. So sources and sinks. You got trees that are going to be sinks. You got the soil that are going to be sinks. You see human emissions in the back are going to be your sources. For example, the burning of coal. Now, one of the interesting things, if we back up a slide to this one, you can see the oceans. The oceans actually hold a lot of carbon dioxide. Now, the scary thing about this, well, I guess it's good and bad. The good thing is they store a lot. The scary thing is scientists really don't understand why they store so much carbon dioxide, nor do they really know how much more the oceans can hold. Now, if you remember earlier in the year, we actually mixed carbon dioxide with water and it created a weak acid called carbonic acid. Some scientists are concerned that all this carbon dioxide being absorbed by the oceans is acidifying the oceans. It's not like you can step into the ocean and burn yourself because it's too acidic, but it's just a very mild process that's taking place. Now, what are the consequences of too many greenhouse gases? First of all, if the climate cycle were to follow its natural course, if you remember from the weathering and erosion unit when we talked about glaciers, the ice age came, it left. It came, it left. It came, it left. And the glaciers are headed back our way, or at least that's what the patterns suggest should happen. And I know as early as the 90s, they were talking about how the glaciers are coming and the ice age are coming. Now, it's not like it's going to be here next week or next year. We're talking about thousands of years. Now it seems like our activities may be threatening to send the climate speeding in a different direction. Now, the buildup of greenhouse gases and other gases have already enhanced the Earth's greenhouse effect. Remember, the greenhouse effect is good. Without the greenhouse effect, the planet would be much colder. We would not be here. Now, an enhanced greenhouse effect, what's it going to do? Well, it's going to make the Earth hotter. Is that good or bad? Well, it depends. Right now, believe it or not, even with this cold winter that we're having, the Earth's average temperature is really good for us humans here. Now, it may take several decades to feel the warming because atmospheric temperatures will only rise significantly after the oceans of the world have slowly warmed. So what is this global warming? Global warming is just what it suggests, that the globe, in other words, the Earth, is warming. And this includes the atmosphere, the oceans, and land. Remember when we talked about climate, we talked about the climate, including the atmosphere, the oceans, and the land. It's not just weather, it's not just the atmosphere. So what is some of this evidence of global warming? Well, here, let's take a look. Here's the global average temperatures from 1860 all the way till about 2008. And an interesting fact is we've had 37 consecutive years of above average global temperatures. So it seems that the Earth is getting hotter. When we look at the top 10 years, the warmest years on record, we see that 2010 was tied with 2005. We got 98, 03, 02. Now we just finished 2013. Some scientists are saying 2013 tied 2003 here for the fourth warmest. So we'll have to wait and see. I've found some charts, and it seems that NOAA is suggesting that 2013 did tie for the fourth warmest, but we'll have to wait and see if that's official or not. Now, the top 10 warmest years have all occurred since 1998. The 2000s, the 2010s, that decade was the warmest decade on record. And the 1900s was the warmest century during the last 1,000 years. Now, you have to keep a couple things in mind. First of all, the 2000s was the warmest decade on record. We haven't been keeping record for thousands and thousands of years. Some of you might be saying, well, the Earth has been hotter in the past, right? Absolutely. So keep that in mind. So what does global warming mean for Wisconsin? Well, historical records indicate that the average global temperature increased by about 0.5 to 1 degrees Fahrenheit between 1890 and 1990. Now, I know some of you might be thinking after a cold winter like we've had during the winter of 013, 014 that a degree warmer might actually be good. And you're probably right. I'd probably suggest with you. I'm getting old enough where, the winters are starting to bother me. But keep in mind, remember we talked about this earlier in the notes. Just a small drop of 4 degrees could send us back to the ice ages. So 1 degree going in the other direction, you can imagine where that may send us. Here's some more evidence. Degrees Celsius above or below the 30-year average. So you can see that there is a trend where for the longest time it seemed like we were getting colder. But all of a sudden since 1980 we've been heading in a different direction. Here we're taking a look at the April global surface mean temperature for the land and the oceans combined, for the oceans and for the land. And you can see for the longest time it did seem like we were getting colder. Now all of a sudden the last 30, 35, 40 years seems like we've been heading in a different direction. Here's another slide showing the variations of the Earth's surface temperature. Again, it seems to indicate that we are getting warmer. Now here's one common misconception. When people think of global warming, they think that the entire planet is warming, and that's not true. You can see from this chart that some places are getting warmer. There's a lot of places here, but if you look closely, there's some blue dots around, so not every place is getting warmer. Some places are actually cooling off. If you think about the cold winter we had during the 2013-2014 winter season, the United States was really, really cold. But we also had the Winter Olympics in 2014 and in Sochi in Russia, and they were actually having higher temperatures than normal. They were actually warmer than normal. So even though some parts of the world are getting colder or had experienced a cold winter, other places were experiencing a warmer than usual summer. So this misconception that the entire planet is getting warmer, it is just a misconception. On average, the planet seems to be getting warmer. Doesn't mean that every planet or every place on the planet is going to get warmer. So what are scientists predicting? Well, they predict the average temperature may rise anywhere from 2 degrees to 6 degrees Fahrenheit. Now, if this seems like a small change, 2 to 4, that's, only 4 degrees. If you go to some of the TV stations, they'll have a 4-degree guarantee. Well, 4 degrees is a huge jump. Scientists really don't know for sure. They have models that'll suggest anywhere from 2 to 6 degrees change, but that is a huge variance. Now, such increases have occurred before in the past, and just never over such a short time period. In fact, the average global temperature has risen more in the last century than at any time in the past 10,000 years. So what does this all mean for Wisconsin? Well, we may experience wetter winters, drier summers, which we have experienced during the past. Longer, hotter, more frequent heat waves. Weather and climate changes that could require farmers possibly to raise different crops because we don't have as much water during the summer because it's drier. Dairy cattle may be stressed by the heat, exhaustion, and growing pest populations may also be a problem in Wisconsin. We may have poor air qualities and higher concentrations of ground level ozone and air pollutants that cause severe health problems. Warmer and more shallow river waters may change the conditions for cold water fish like trout. Denser algae blooms, lower oxygen levels in ponds could affect the aquatic life that's living there. We may have more frequent floods, droughts, forest fires, and damaging storms, and changes in tree species that could affect the forest industry and wildlife populations. We may even have an increase in disease-carrying insect populations. Remember, there's a lot of things such as dengue fever and malaria that these diseases are carried by insects and spread by insects. Now, is there ever other evidence out there? Well, yes, we can look at things like leaves. And these are the dates that oak leaves first show their leaves. And you can see that in the 1750s, the oak leaves would first show their leaves on average towards the end of April. Now it seems like, and here's the year 2000, it seems like the leaves are coming approximately 10 days earlier than they were, well, a century and a half ago. When we look at Wisconsin, the 1970s to the 2020, so we're looking at approximately 50 years. And again, we're predicting out in the future. So even if we go to 2010, you can see because there's more purple here, we have gotten warmer in Wisconsin. Here's another chart. This is where they're predicting way out into the future. And scientists are predicting that Wisconsin's going to continue to get warmer and warmer and warmer. So let's look at a blown up scale of these two states. We have 1960 and we have 2010 here. So it's not a huge change, but it is a subtle change. Now remember, all these potential changes are just that. They're just potential changes. It's difficult to predict anything with certainty on this planet because you never know what's going to happen. Now again, it sounds like global warming is happening, and as a scientist, I'm going to probably say yes. It seems like global warming is a certainty. It seems like it's happening. Remember, the whole theme for this unit is why is it happening? That you're going to have to make the decision on. If we look at the facts, it seems like the Earth is getting warmer, but why? Why? That you're going to have to decide for yourself. You need to look at the evidence, and you need to decide what side you're going with. All I ask that you do is base it on the evidence. Thank you. This does conclude part 4. And again, there's just one part left. Again, I'm trying to keep all these videos as short as possible so that way you can take these notes in short little spurts. Thanks.